Okay, so we have here problem number 1. This is in relation to the relative density of soil topic. A silty sand has a void ratio in loosest condition equal to 0.88 and a void ratio of 0.40 in its densest or in the densest condition. If the relative density of sand is 65%, compute the following. Letter A, in situ void ratio. Letter B, porosity. And letter C, if the dry unit weight of the silty sand is 16.85 kilonewton per cubic meter, compute the specific gravity of the sand. Okay, we're going to solve the problem number 1 on relative density of the soil. So let's put first the given from the problem. So we have in the problem, we have the type of the soil is a silty sand and it has a void ratio in a loosest condition. So as we all know that the void ratio in a loosest condition, that is equivalent to the E maximum. So the value is 0.88 and we have a void ratio in the densest condition, so that is equivalent to E minimum. So the value given is 0.40, and then we have also a given that is the relative density, that is denoted as dr, that is equivalent to 65%, or this is equivalent to 0.65. So compute the following. So let's have first the letter A. So what is asked in the letter A is the in situ void ratio. So what is the in situ void ratio? So in the equation we're going to use is the equation for the relative density that is in relation to the void ratios. So we have the equation. So what is asked in here is the void ratio E, or the natural void ratio, or the in situ void ratio. So the equation to use is d sub r is equivalent to E maximum, or the void ratio in the loosest condition, minus the in situ void ratio all over E maximum minus E minimum, or the void ratio in the densest condition. Okay, we're going to substitute the equation, or you may be able to derive the equation. To derive the equation here, so we're going to transpose this equation at the bottom in here. So to derive this one, we will yield this equation, that is the in situ void ratio, that is equivalent to E max minus dr multiplied by E max minus E min. So that's the equation. So we're going to substitute the values in the given. So we have E is equals to the E max, that is 0.88 minus 0.65 for the dr multiplied by the E max 0.88 minus the E min, that is 0.40. So calculating this one, so we have the value that is 0.568, or that is equivalent to 0.57. Okay, for the letter B, what is asked in the letter B is the porosity. So the porosity is denoted as N. So the equation for N, since we already have the value computed a while ago, that is E, that is equivalent to 0.57. So for the N, we have N is equivalent to void ratio over 1 plus the void ratio E. So we're going to substitute the values from the given. So we have 0.57 all over 1 plus 0.57. So calculate this one. We will have a value of 0.36. So that is our porosity. For the letter C, the question here is, if the dry unit weight of the silty sand is 16.85 kilonewton per cubic meter, compute the specific gravity of the sand. So we have already computed a while ago the letter N, or the porosity N, that is 0.36. And then we're going to solve for the dry unit, for the specific gravity, given that there is a unit weight dry that is equivalent to 16.85 kilonewton per cubic meter. So to solve for that one, as you can see in the given, we can use the equation for the unit weight dry in relation to the specific gravity and the void ratio. So we have the equation for the unit weight dry, or dry unit weight, that is gamma D equivalent to specific gravity GS times unit weight of the water over 1 plus E. So we're going to solve for the value of GS. So we're going to derive the equation from this one, or you may substitute the values given on this equation, or you may try to derive the equation. So to derive the equation from this unit weight dry equation, so we will have GS, or specific gravity, that is equivalent to unit weight dry times 1 plus E over unit weight of water. So we're going to substitute the values in here. So we have the unit weight dry, that is 16.85 multiplied by 1 plus 0.57. Okay, that's 0.57 all over the unit weight of the water, that is 9.81. So calculating this value, we will yield the value of 2.697, or this can be 2.70. So that is the specific gravity of the soil. And that's our solution to the 3 unknowns for the problem number 1.